Evaluate the shape functions n1, n2 and n3 at the interior point P. The triangular element is shown in figure. Evaluate the shape functions n1, n2 and n3 at the interior point P for the triangular element is shown in figure. So this is the triangular element, first node, second node and third node, points 1.5, 2, 7, 3.5, 4, 7. At P is 3.85, 4.8. Evaluate the shape functions n1, n2 and n3 at the interior point P for the triangular element is shown in figure. This is the triangular element, first node, second node and third node. The coordinate points x1, y1, 1.5, 2, 7, 3.5, 4 and 7. So solution x1, y1 is equal to 1.5, 2, x2, y2 is 7, 3.5, x3, y3, 4, 7 and p is equal to x, y. Therefore 3.85 and 4.8. And x is equal to n1 x1 plus n2 x2 plus n3 x3. X is equal to n1 x1 plus n2 x2 plus n3 x3. Since n1 is equal to xi, n2 is equal to neta, n3 is equal to 1 minus xi minus neta. Therefore x is equal to xi replace n1 replace xi, xi x1 plus neta x2 plus 1 minus neta minus xi x3, xi x1 plus neta x2 plus 1 minus xi minus neta x3. Therefore xi x1 neta x2 x3 x3 into xi minus x minus xi x3 minus neta x3. Therefore x1 x3 x1 minus x3 xi plus x2 minus x3 neta plus x3. Substitute all values. X value 3.85, x1 is 1.5 minus 4 to xi plus 7 minus 4 into neta plus 4. Therefore 3.85 is equal to minus 2.5 xi plus 3 xi plus 4. Therefore 2 xi minus 3 neta, 4 minus 3.85, that equal to 2.5 xi minus 3 neta is equal to 0.15 from 1. Therefore x is equal to n1 x1 plus n2 x2 plus n3 x3, where n1 is equal to xi, n2 is equal to neta, n3 is equal to 1 minus xi minus neta, where xi is equal, x is equal to xi x1 plus n2 x2 neta x2 plus 1 minus xi minus neta x3. Therefore x is equal to x1 minus x3 xi plus x2 minus x3 neta plus x3. So substitute all values, x value, x1 value, x3 value, x2 value, x3 value, x3 value. Therefore x is equal to 3.85, that equal to x1 value 1.5 minus 4 into xi, x2 is 7 minus 4 neta plus 4, that is equal to 3.85 minus 2.5 xi plus 3 neta plus 4, that equal to 2.5 xi minus 3 neta is equal to 4 minus 3.85, that equal to 0.15. And similarly y is equal to n1 y1 plus n2 y2 plus n3 y3. Since n1 is equal to xi, n2 is equal to neta, n3 is equal to 1 minus xi minus neta. Therefore y is equal to xi y1 neta y2 plus 1 minus xi minus neta y3, that equal to xi y1 plus neta y2 y3 minus xi y3 minus neta y3. Therefore common, xi is common and neta is common. Therefore y1 minus y3 xi plus y2 minus y3 neta plus y3, y1 minus y3 xi, y2 minus y3 neta plus y3. Substitute all values, y value, y1, y2, y3 values. Y is equal to 4.8, that equal 2 minus 7 xi plus 3.5 minus 7 neta plus 7, 4.8 minus 5 xi minus 3.5 neta plus 7, that equal to 5 xi plus 3.5 neta that equal to 7 minus 4.8. 5 xi plus 3.5 neta that equal to 2.8 from equation 2. For solving equation 1 and equation 2, xi is equal to 0.3 and eta is equal to 0.2. For solving 1 and 2 equations, xi is equal to 0.3 and eta is equal to 0.2. Therefore, n1 is equal to xi is equal to 0.3 and n2 is equal to neta is equal to 0.2. Therefore, n3 is equal to 1 minus xi minus neta that equal to 1 minus 0.3 minus 0.2 that equal to 0.5.